Part 2 is solving 2D motion problems. So we got our knowns and unknowns. We got everything set up. Now we're ready to solve. So we're going to use the y direction because that's what I have enough information for. I'm solving for time. I have d, a, and vi. So I'm looking at my equations here. And you'll notice that I identified a couple of things in the equations. For example, I identified that Old Faithful, Big Chalupa, Ain't Got No Time are all y direction equations. And that's because they're free fall. Whereas the x direction is constant, so we're just using v equals d over t. And then when we get to the vector triangles, this is just a recap. We use Pythagorean theorem to find c, so the resultant vector. We use tangent to find theta, the angle. We use cosine to find a, which is the x value or the horizontal value. And then we use sine to find b, and that's the vertical value. So I need an equation that is free fall, so one of Old Faithful, Big Chalupa, Ain't Got No Time. And I need one that's got D, VI, A, and T. And the only one that has that is Big Chalupa. So that's what I'm going to use to solve here. So Big Chalupa is D equals VIT plus 1/2 AT squared. So I'm using my Y displacement of 6. I'm using my y velocity of 0, not the 3.5. I'm using only y numbers. I'm using t, okay, plus 1/2 times a, which is 9.8, times t squared. So 0 times anything is 0. Half of 9.8 is 4.9, so you get 6 equals 4.9 t squared. And just to save us time, again, I'm not as worried about the algebra right now. You can ask me those questions if you have them later. When you solve this out, the answer you're going to end up with for time is 1.1 seconds. So now we get to C. And once I've done this, I'm going to go ahead and add that to my chart. I'm just going to go ahead and add it in here. Because now I can use that for all the rest of the problems I'm going to do at 1.1 seconds. So how far out from the edge of the pool did Jalen land? So that was this D here. So that is an x direction D, which means I'm going to be using my x direction equation, which is v equals d over t. All right, so we're using only x things now, no y things. So v is 3.5. D is what I'm solving for. T is 1.1. When you solve that out for D, and again, this depends on if you round or don't round. I use non-rounding numbers, so my number's a little closer to what it should be, but don't worry if you're off by just a few decimal points. This would give you 3.87. I know a lot of people got 3.85. Notice again, I didn't use any y numbers. I just used x ones. All right, here we go. We are almost done. So last thing we need to do is figure out Jalen's velocity right before splashing into the water. So what I note about Jalen's motion is that they're going forward. And the x forward velocity should be the same because there's no y velocity or no y acceleration to change it. But the downward will change, and that's because gravity is acting on it down, so there won't be any to start with. It'll get a little bigger, much bigger. And this would be the resultant vector here. Yeah, let's do a different color. So I'm looking for this here at the end, this purple one. That's what I'm trying to find, that purple arrow. So how do I do that? Well, that looks an awful lot like my trig stuff that I just did. It looks an awful lot like one of these kind of ABC triangles. And that is exactly what it is. So the last thing we need to talk about is how do we go about solving for the final velocity. Sorry, this should be a bullet point. So how do we go about finding that? Well, the first thing I need to do is I need to draw my, my vector triangle. So I have a forward velocity, a downward velocity, and then that resultant vector velocity. So the first thing I need to do when I'm solving for v final is sorry, mine is blinking. First thing we need to do is draw the vector triangle. Okay, so I drew the vector triangle. Now I need to label my A and B, or you can think of them as X and Y. Now, are these X and Y displacements, velocities? What are these? These are going to be velocities. So this is going to be A, or you can think of it as the X velocity, and this is going to be B, or you can think of it as the Y velocity. Okay, so what is the x velocity? Well, the x velocity never changes. So if it started at 3.5, it's always going to be 3.5. Y, on the other hand, is different because the y velocity did start at 0, and it is going to be going faster as I go down. So it's not going to be 0. It's going to be something else. And we're going to call that something else v final, because that is what it is at the end. And I don't know what that final velocity is. So I need to solve for that. So the first thing I do after I draw the vector triangle is I need to solve for Vf in the y direction. So I've identified that I need to find the final y velocity in order to solve this. Well, that's the only thing I don't know yet in my chart, so I might as well find it. And that's what we're going to do first here. So final velocity, we're going to be doing a y column thing, so we can only use y equations. So, well, I've solved everything except for final velocity, so I might as well use Old Faithful. It's going to be the easiest, and that's what I'm going to do. So v final equals v initial. Again, I need to use only y numbers, so I'm not using 3.5. I'm using 0 because it's the y initial, plus a, which is 9.8, times t. Again, don't worry if you're off a little bit by rounding here for what my answers are. And the answer I'm getting for v final is 10.78. Okay, now that I've found the final velocity, I need to find the actual final velocity, because this really isn't the final velocity. It's the final velocity in the y direction only. I need to find the actual total velocity. I need to find c. I need to find the resultant vector. And that's what I'm going to do now. And that's this here. So find v final, draw the vector triangle, solve for v final in the y direction. Now you're going to find c and theta, magnitude and direction. Okay? So a squared plus b squared equals c squared. So 3.5 squared plus 10.78 squared equals c squared. So the value for c, the resultant vector, the magnitude, is going to be 11.3 once I solve that out. And the last thing I need to do is find the angle using tangent. So tangent of the angle, which I don't know, is equal to b over a. So b is the 10.78 over a, which is 3.5. So you would divide those numbers out first. Once you divide them out, you do the negative tangent, tan negative 1, or inverse tangent, because that's the opposite of tangent. I don't want tangent theta for my answer. I want theta. So I got to do the opposite of tangent, which is inverse tangent, tan negative 1. When I do that, I get my final answer for theta to be 72 degrees. And there is my answer for the problem. Now, one other thing I want to mention, why didn't I use 6? So it seems to me like the obvious choices for these here would be 3.5 because that's the forward, and 6 because that's the down. So why am I not using those? Well, two reasons. One is the 3.5 technically is only for the beginning. Now, it is constant, but it is only for the beginning. And the 6 meters is only the measurement at that point, right? It's the total displacement, but at the end, the displacement is 0 if we're just looking at the end motion. So that's one reason. But the bigger reason is this is asking about velocity, but this is a displacement. So we can't use a displacement number when we're solving for velocity. So that's just something to kind of keep in mind when you're doing this. All right, so we did a lot. Okay, this is a big, giant, massive problem, and it takes 2 whole recordings, essentially. So what I want you to do is try practice 2, number 1. And the good news is practice 2, number 1 is basically the same type of problem, just the numbers are different. And so I want you to try to use that to use this one to try to help you solve it. So the suggestion I give is try to do it on your own, but if you have trouble, look at number 3. So did I do my diagram? Okay, did I draw the motion? Did I label the givens? Do I identify positive and negative direction? Okay, I did that. Did I do my knowns and unknowns? And then I just kind of start going through the list. Again, try to do as much on your own as you can, but if you get stuck, know that this problem is like the example we just did, only the numbers are different. So hopefully you found this helpful. Let me know if you need any help. And like and subscribe like a boss! No, I'm kidding. Please don't do that. I really don't care. Anyway, have a blessed day. Thanks, y'all.